Hello everyone, thank you for passing by to hear this online training about the fundamentals of glass fiber reinforced concrete GRC. My name is Carmen and I'm a research specialist for Cementir. I have been working with white cement applications for the last 6 years and it's my pleasure to talk to you today about GRC, one of my favorite applications in terms of aesthetics and versatility. In this presentation we will cover the following topics. What is glass fiber reinforced concrete, or GRC, the materials used for making GRC, types and grades, manufacture and quality control, some crucial points when working with this technology, the strategy that our research department SART is implementing to support GRC applications, and finally, I will show you some stunning GRC projects made by our customers using Aalborg White cement. Glass fiber reinforced concrete is a composite material produced by reinforcement of a cementitious matrix with alkali-resistant glass fibers. If we look at the recipe itself, it is composed of cement, fine sand, acrylic, superplasticizer, and alkali-resistant glass fibers. The cement used for this application is mainly white because it's a highly aesthetical application that benefits of the whiteness, either because the elements will be white or because pigments will be added to target a desired color. Now let's take a look at each component of the mix separately. The cement used is normally ordinary Portland cement, OPC, rapid hardening Portland cement, or as I said before, white cement. The sand is quartz sand mainly. It must be supplied washed and dry to target a correct water to cement ratio, and the maximum particle size is around 1.2 millimeters. In some cases, for premix application, it can reach a maximum of 2.4 millimeters, but it's more common to target less than this. In the table, you can read some important properties that the sand must fulfill. This information is provided as a guideline by the International Glass Fiber Reinforced Concrete Association, GRCA. Acrylic is also commonly used inside the mix to ensure that there is sufficient retained moisture for the hydration. This is important because usually GRC products are very slim. Adding the acrylic can prevent to some extent the crazing of the surface, of course, together with best practices at the production site. In the table, you can find the target properties for the acrylic used in GRC. Superplasticizers are water-reducing admixtures. Typically, the water-to-cement ratio for GRC should be around 0.3 to achieve the durability and mechanical properties needed. This water-to-cement ratio will not be possible without the use of a superplasticizer. When choosing the correct SP, it's very important to carry out flow tests and visual inspection of the mix to assess the SP compatibility with the cement and avoid flow loss or segregation. Other materials used can be pozzolanic materials, silica fume and metakaolin, pigments, paint, sealers, coatings, adhesives, hydrophobic admixtures, viscosity modifying agents, retarders, accelerators, and titanium dioxide for the whiteness. Fibers are a very important component of the GRC because they allow to fulfill the flexural properties needed. The use of alkali-resistant fibers is mandatory, otherwise the high alkalinity of the cementitious system will destroy the fibers in hours. Alkali-resistant fibers must have a zirconia content of at least 16%. Durability of GRC will be very compromised if the fibers are not alkali-resistant. Currently, there are two types of GRC, spray-up and premix. The spray-up is made with a sprayed gun like the one in the picture to the left. One robin of glass fibers is fed continuously into the gun, where the strand of fiber is chopped to a length of 25 to 37 millimeters and projected out of the nozzle by compressed air. At the same time, the mortar is pumped to the nozzle where it is atomized and sprayed out, mixing with the fibers. Normally, the dosage of fibers is around 5% by weight. When making premix GRC, which is the other type, a simpler gun is used. You can see it on the picture to the right. In this case, the GRC mortar is mixed with the pre-cut fibers at a dosage between 2 to 4% by weight, and then after is sprayed. The differences on the production processes of GRC can lead to different grades. Normally, a spray-up GRC can reach grade 18 and above due to its higher content of fibers, while premix GRC can be between 8 and 10 grade. The grade is related to the flexural properties of the material, specifically the modulus of rupture, MOR. The P after the number denotes the presence of acrylic into the mix. In the slide, you can see a typical load versus deflection curve for GRC, courtesy of Power Spray. It is possible to see the different behavior of the material according to its grade. The higher the grade, the higher the load needed to reach the MOR, or modulus of rupture. This is a very useful table, courtesy of the GRCA, that shows the most common grade needed to fulfill a specific market sector and typical application. I will not go through it by detail, but please take a look at it when you have the time for it. Mainly, GRCA is used into the architectural market in the form of highly aesthetic and non-load-bearing elements. So, choosing between a spray-up and premix must be based on the target properties of the final products to fulfill the application that is meant to. The table in this slide is only a reference for a GRC recipe. In a GRC production plan, the recipe must be adjusted and tested before producing the final elements to check if the right workability and mechanical properties are reached. I will also advise to check the finishing of the element and look for some imperfections that could be related to the mix design, such as air voids or segregation marks. Some important points for the mix design are: the sand must be preferably silica sand, and the maximum particle size should be around 1.2 millimeters for spray-up GRC and 2.4 millimeters for premix GRC. Please always check with the provider of the spraying machine, and they will tell you the maximum particle size that you could use in the sand. The function of the acrylic polymer is to allow the curing under normal conditions. Otherwise, the curing must be done in a chamber with 95% of humidity to avoid, for example, the crazing of the surface. Pozzolanic additions are allowed, as silica, metakaolin, and so authors report improvements in the durability with the addition of those. Always make workability and mechanical tests before adding any material to the mix. Nowadays, the use of hydrophobic mixtures is common, especially for highly aesthetical applications like GRC. There are several brands in the market, and as I said before, make a prior testing of this before casting the real elements. This is a typical GRCA spraying machine. The image is courtesy of Power Spray. The machine usually brings the equipment needed to produce both types of GRC, spray up or premix. This is a machine, for example, that we have at our Research and Development Center here in Aalborg, Denmark. In this slide, I try to outline the production process of GRC. This is a basic representation of the production process, and of course, each producer has its own unique technique. In GRC, the quality and finish of the elements depends not only on the recipe, but also, to a large degree, on the skills of operators. Before operating the machine, the user must have a proper training. Now, let's go through the production process. For a spray up, first, the user needs to calibrate the fiber output using the back test. Then, calibrate the slurry output using the bucket test. The slurry is then mixed and placed in the GRC spray station. The user first spray a thin layer without fibers, known as a spray mix coat. After this, spray the GRC into the mold, finishing with cleaning the machine. The production process can change from plant to plant, especially to make the most detailed shapes with very challenging molds. For the premix GRC, the GRC is mixed and a small portion is taken for the mist coat. Then the fibers are added. The mist coat is sprayed. Then the GRC with fibers is also sprayed into the mold, and the cleaning starts. The table shows the whole test program for GRC according to EN standards. The ones marked with the red arrows must be part of the QC plan at the production site, meaning that at least the glass content and the flexural properties should be measured. The flexural properties are the heart of the QC system, since the results will be used to determine the grade of the GRC. The plant is responsible of designing and undertake the QC program. I recommend running all the tests in the table every time a new recipe is introduced. As I said before, the flexural properties are the heart of the QC for GRC. In the image, you can see the typical setup for the flexural test according to EN 1175. It is a 4-point bending test made on a specimens cut from a test board sprayed with the same material used to produce the elements but without the mist coat. For specific dimensions, instructions and calculations, please check the standard. The test will generate a load versus deflection curve from where the deflection and load can be assessed. The deflection and load at the limit of proportionality, LOP, corresponds to the point where the linearity changes, as you can see in the graph. The deflection and load on failure, modulus of rupture, MOR, corresponds to the maximum load value recorded. For GRC, bending strength is the most important test because it defines the grade of the material. Spray-up GRC has a higher MOR, modulus of rupture, due to the fibrous arrangement in the cementitious matrix, which must be mesh type. Spraying technique is the parameter that most affects the flexural strength. Some crucial points to keep in mind about GRC. The quality of the fibers must be ensured. They must be alkali resistant with minimum 16% of zirconia content. The use of glass fibers is not allowed. The election of the right superplasticizer is extremely important because a wrong one can cause bleeding, segregation, low 24-hour strength, etc. So compatibility studies between the cement and the superplasticizer must be done before spraying. The spraying technique will define the development of the material, which makes training mandatory. Also, the identification of the elements with the name of the person who sprayed can help to find a trend between different operators. Now, I would like to talk a little about how Cementery in my department, SART, Sustainability and R&D Group, is contributing to grow this application. Cementery became member of the GRCA to be in close contact with the main players, you, and to get updated information about how the technology is evolving worldwide. SART also gives technical assistance to our customers around the world, and our results can translate directly to the real production process because we have a full-scale GRC spraying machine in our laboratory that we use to test all the parameters needed on the real specimens. We are also continuously undertaking technical studies according to the needs of the market, such as compatibility between Aalborg White and superplasticizers, also any other admixtures, durability, high-performance mixes. So please feel free to reach us if you have any technical issue that we can work on together. Now we will take a look at some beautiful GRC projects worldwide made by our Aalborg White cement customers. Enjoy! This will be the Broad Museum, GRC cladding, the architect dealer Escofidio Renfro, Willits Construction, Los Angeles, California. This beautiful building will be Lunen Marriott Hotel, also GRC cladding, SOM Architects. The precaster will be Beilida and Shanghai. In the next two slides, you will be seeing a multi-bridge form commercial building. The architect is Thong Main and the precaster is Beilida. The building is located in Sejong, Korea. Now you can see the Sky Park complex. It's a project from Zaha Hadid Architects and the precaster is Vibe Fiberbeton. The building is located in Bratislava, Slovakia. And here you can see the details of the elements. This is the Merck's building, Research Center for Lifestyle Diseases. It's located in Copenhagen, Denmark, also from Vibe Fiberbeton and the C.F. Müller Architects. a closer look into the building. This will be the Metropolis apartment building. Future system Casper Danielsen Architects. The precaster is also Vive Fibre Beton and is located in Denmark, in Copenhagen area. A closer look. Thank you so much to our customers that allowed us to share their wonderful projects in this presentation. And thank you all of you for listening. Please reach for comments, input, or questions. And I wish you a wonderful day. See you in the next presentation. Bye bye.